All right, so schedule-wise, let's see. So either today or tomorrow, we're going to go over the leap year assignment, although I will probably do a talk first. And by assignment, I mean in-class exercise, not assignment, in-class exercise. So we'll do the leap year thing in class either today or on Tuesday. Also, I'll be going over the in class about the for loops and functions and if statements in more detail. On Thursday, let's see. On Thursday, we have, I will go over the practice exam, right? Because I've sent out the practice exam. Thursday, I'll go over that practice exam. Friday will be your exam if you have a Friday lab. Monday will be the exam if you have a Monday lab. You'll also get your you'll get the while loop assignment, which it's not so bad. If you want to give that, which it's the Mario and Cash and Credit lab for lab 6 that will be assigned on the 23rd. It for some reason had a due date of the 23rd from the import, but I went ahead and bumped that back so it's due on the 1st. So if you had a bunch of assignments due on the upcoming Friday, it's no longer is the case. Okay. Now normally, let's see. So yeah, I'm gonna also need to go through and make sure that the calendar still makes sense, and that we won't run out of time with the semester and still have plenty of time to do the final project in the sequence that we have. But hey, it will fit. So I ended up doing these problems that included if statements and functions at a point where they had not been introduced. So that gave you it gave you first exposure that wasn't necessarily, easy. So I figure that today what I'm going to do is I'm going to go over some of the I'm going to go into more detail about the if statement in class, as well as writing functions, okay? And then we will start on the leap year assignment, and we may not, or in-class exercise. We may not finish it today, and we'll go over that on Tuesday. On next Tuesday when we don't finish it. Now for Module 6, which will be next Tuesday, okay, that's an old page, old link, so that's an old dead link. So on Tuesday, edit that so that we don't have any panicked students. I'll remove that, which said we held exam 1, which that's when it used to be. So instead we're doing it in lab 6 rather than the first lecture of week 6. So okay. And then remove that link to that quiz because that is no longer existing. Okay. So, all right. And when I say leap year assignment, I mean Blaine Pope Gregory, which we'll get into in a bit today. Okay, so first off, let's go ahead and talk about functions just very briefly, and then I'll show you some things that we can do with if statements and kind of the way they work, and then we'll implement them in practice with the leap year assignment, the Blaine Pope Gregory. It turns out they're not too bad, and for the leap year assignment, Pope Gregory, it's not so bad until we actually have to figure out is it a leap year or not. But once we get there, we'll be able to figure that out. So functions are essentially verbs in the programming language. I've said this a few times, but it bears worth mentioning. For instance, the int keyword, which takes in a list of numbers, 1 plus 2, sorry, no, that's sum. The int keyword, which takes in an integer, takes in anything and converts it into an integer. So let's see, int 34. So that is a function. It's a word that's defined, and it requires an argument to work. Well, apparently not. Just gives me an int if I don't provide one. Let's see, can I provide that? Nope. One of the things about functions is that they require a certain number of you to feed some amount of things to them in order to work. Feed them too much, and they'll crash. Feed them too little, and they'll crash, with some exceptions. Okay. So int takes in anything and converts it into an integer. That's a function we know. Sum takes in a list of numbers, as I was saying, 1, 2, 3, 4, 5, and it goes ahead and converts them into. It adds them together into one big, integer in this case. Okay. So these are all kind of commands that are baked in. There's a number of them, like max, which takes in some number of arguments, 1, 2, 3, 74, and gives you the biggest one in there, right? These are things that are built into Python. Print is also a function. Now, the idea here with functions, again, is that we can make our own, okay? We can make our own functions. This is the most basic function I can basically write, which is just a function that simply will which will simply print out something. Def, say hello. This is the lecture I should have done on Tuesday, but hey, that's fine. Say hello, which will print hello. Okay, and if I run it, it's not going to do anything. One cool thing about this, about using idle that you won't necessarily be able to do if you're using VS Code, is that once you run it, okay, technically the program is still running, or it's ran, but you can still access what you did in here. So for instance, x says there is no x. Let's go ahead and say in this one, x is equal to 5. Again, this works in idle. X is equal to 5, doesn't do anything. But now if I say x, it'll print out 5 because I defined it in here. So this is a good way you can test things on over here in idle. Now if I say hello, it says that say hello is a function. What I've done here is I've used def, which is short for define or define function. Then I've said say hello. I've said this is the name of this function, and this is the list of parameters it takes. Okay, parameters versus arguments. I'll get into in a sec, but don't worry if you messed it up because everybody messes it up and nobody cares. So this basically says, hey, I've defined a function here, and it's going to do all the things in this function when I call this verb, this new function. So to call it, to actually do this function, I have to invoke it, which is where those parentheses come in. This is the difference between talking about some kind of action and actually doing the action, right? You're rarely going to do this. You'll almost always be doing this, where we basically say, okay, to do the verb I've created, to call the function I've created, I use parentheses. We use the formal term is we invoke this function, which I always like because it sounds like I'm doing magic. So that's pretty cool. But again, this is just a very kind of straightforward thing we can do here. Print world. And rather than now calling it through here, I'm just going to call it in the script like I should normally do. Say hello, open parentheses, close parentheses. So I define the function, and then I call it. You can't do it the other way around. You'll get an error if you try to do it the other way around. It says, because remember, your Python reads from the top to bottom. So it's going to go, say hello, what's that? There is no say hello function. I'm gonna crash because we ran it, tried to do this function, we looked for it, it doesn't exist. Oh well. So over here, let's just add one. And again, these things can be as nice as, this can take as much indentation as you need it to take. So for in range 3, hello world, hello world, hello world, right? So calling say hello runs this loop 3 times. When each time the loop runs, we say hello world, hello world, hello world. Everybody following so far? Yep. Hopefully some of you have seen this already. If you haven't, that's okay. Again, I like to kind of introduce these as though this is the first time. So now, what are we going to do? So now what we're going to do is we're going to write a function that takes in an argument. Def double this. And I'm going to just simply say num. Now, what double this is going to do is fairly straightforward. I'm going to print 2 times the number. Make sense to everybody? If you give me a number, I'll print twice of what it is. So let's go ahead and call double this 5. No surprises, that gives me 10. If I call it, and I'm allowed to call it more than once. 5, 10, 15. Doubling those will give me 10, 20, 30. Now there's no safeguards right here in Python. The way this is currently written, there's no safeguards, and unlike in other languages. So nothing is preventing me from doing this. 2 times string and doubling the string, right? There's nothing that prevents me from doing that as long as it's, and Python doesn't check the type. It doesn't even know what you passed it until it has to use it. And if you try to do something with a type that you can't do, like say this was minus instead for some reason, it won't figure it out until it actually tries to do it. So, but anyway, so even though I kind of specified a number, it's not going to prevent me from putting anything else in. That's one of the nice freedoms, but also dangers of Python. So we've got this, double this, and it takes this number in. It's got a parameter over here that we take in, and we feed it these arguments, 10 and 15. Parameter over here, arguments over there. I may have reversed them. Honestly, honestly, I have to look it up every time. So don't worry about it too much. If you say parameter versus argument, everybody's going to understand what you mean. 10. So this requires a number to work. If I try to do it without a number, double this, blank, it's just going to crash. 20, 30, and then it tries to do it without a number and says, you're missing one required positional argument, num. This is a positional argument. If I try to give it 2 arguments, it'll say, it takes 1 positional argument, but you gave me 2, right? Think of it as a contract here. This basically says, you give me 1 input, you give me 1 input and I will do and I'll be able to do the thing that I say I can do. Now, part of the issue is suppose doubling a number was actually like a really hard, really complicated operation that involved a lot of instructions, okay? It's not, but pretend like this is a really hard operation that we created for the computer right here. And suppose I wanted to figure out what the sum of doubling 10 plus doubling 15 is. I mean, it's fairly easy for us to find out, 2 times 10, that's 20, 15 times 2, that's 30, so it's 50. Now this is where we get into the return statement, because if I try to add these things together and then print out the result, I can't. It's going to tell me, okay, we've got 20, we calculate 30, right? It does this, then it does this, and then we try to add this together, but we get unsupported operand types for plus, none type and none type. There's a lot that's going on there in that, but what it's saying is that when we print something, it's just for humans. The computer doesn't see this. that we're printing out 20 or 30. It just simply outputs that so that we can see it, right? But with functions, a lot of the time what we need, okay? With functions, a lot of the time what we need is for the function to be able to communicate back with us, or to be able to use the information we get from the function. So this is an input. If we instead change this to return, that allows us to get the output out of the function. Input into the function, output from the function. Okay? So now if we run it, double this plus double this gives me 50. Why is that? Well, let's go ahead and break it out a bit more. Num1 is equal to double this. Num2 is equal to double this. Okay? So nothing wrong with me making two calls like that. Print num1 plus num2. 50, right? So over here, num1 is doubling this. This becomes 20. We can print these out individually. I'm just going to print out that one because you'll be able to see. So we calculate this, and returning it gives it basically says, aha, if I've returned this, then I'm going to replace, once this function call is done, I'm going to replace it with what's been returned. Make sense? Now, you don't need returning for lab 4 and 5. You'll need it, or for the exam, I don't think. But for lab 6 and going forward, you will definitely need the return function. Similarly, we're going to be migrating away from using the input statement in favor of doing arguments. We don't really want input statements inside of our functions. We want them outside of our functions if we use them at all. Okay? Because that will make testing a lot quicker, because every time we call an input statement, the program pauses and we have to type stuff in. So, okay. So returning is pretty darn useful here. Let's go ahead and now combine, let's go ahead and just do another one. Okay. Def add. So this one's rather silly, but straightforward, but it's going to help us illustrate a few things. I'm going to go ahead and comment out this bit over here. We don't need it right now. We're at all. Add x and y. Guess what that's going to do? It's going to add two numbers together, yes. It's just going to simply return. I'm going to say total is equal to x plus y, return total. Okay. Print add x. So what am I going to do? I'm going to do 5 plus 6, which will give us 11, right? No surprises there. It's going to give us 11. Okay, make sense? Okay. Okay. So, let's see. All right. So now I need to kind of demonstrate a bit of a subtlety here. Okay. X is equal to 42. Print add 5, 6. Print x. Remember, Python and programming languages in general, so Python specifically wants to operate under the principle of least surprise, meaning it does the least surprising thing. Furthermore, it wants to make your mental load while programming as small as possible. Add 5 plus 6. Okay, x, so we're just adding 5 plus 6. And so what happens when we do this? What happens is that 5 gets stored in x, 6 gets stored in y, we add them together, store the result in total, return total, and that comes back over here. Okay? We print x out here. Notice that I use x here and x here. The key takeaway from this is that nothing I did in here with the x over here affected the x outside of the function, right? Think about how annoying that would be if you had to remember the name of every single variable you used inside and outside the function in a large program. Think about that. So the key takeaway here is that what happens inside of the function stays there, essentially. This name, I think the formal term is overshadowing. When you're inside the function, okay, this x is the one that exists when you refer to x, not this one. Make sense? When you're inside the function, when you mean x, you mean the one that's inside this function, right? You're not going to confuse it with any x's or y's outside the function. Make sense to everybody? Keeps it simple. You can think of your and really it is that simple. Just think of when you do the function, think to yourself, no other variables exist inside this function other than what's inside this function and what I'm bringing in via the parameters. Okay? Make sense to everybody? That means you can name your parameters whatever you need them to, and you don't have to worry about, overloading your names. You don't have to worry about using multiple names. Yes?
Can you do X, Y, Z and then put 5, 6, and 1 or no?
5, 6, and 1? Like on the exam?
No.
Practice exam?
Either one. Here or exam. I'm just asking if it's possible.
I mean, I could. You mean, can I make a one that does 3?
Yeah.
Yeah, nothing stops me from I'm going to call it add 3, just to distinct because it has to have a unique name. X, Y, and Z, and that's actually a good place to go with this. Total is equal to X plus Y plus Z. Return total. Okay. Let's go and add 1 to there. Okay, so add X, Y, Z. Oh, add 3, right? Because I called it a different function. Okay? And then it adds those together. I can also call it, XY. I could also call it XY and foo. There's nothing stopping me from naming the variables, stuff like that. I can also call it spam and eggs, which are in Python the metasyntactic variable names. What? Metasyntactic variable names. So metasyntactic variable names are basically the words we use as kind of to explain. They're the name for variables other than like temp or something. They're placeholder names for variables. So spam and eggs is in Python named after the Monty Python spam and eggs skit. In most other programming languages, it's foo, bar, and baz, and that comes from, I think it's American military lingo. It's foo, bar, and baz, which comes from foobar, which stands for something along the lines of fouled up beyond all recognition. Something along the lines like that, except less PG. And other languages, and I mean like French, have different variable names than that. Just so when you see spam and eggs and foo, that's why you're seeing them. They're just kind of standard placeholder names. So here, okay, all right. So on the practice exam. So I'm gonna give you a heads up here because this is something that is on the practice exam. Undetermined whether it's going to be on exam 1 or exam 2. If it's not on exam 1, it's definitely going to be on exam 2. And as a bonus, I know for a fact it will be in 1068's exam 1. So I know Professor Fiore loves to ask this kind of question, which is something along the lines of this. And we'll explain it. So spam is equal to 1, eggs is equal to 2, foo is equal to 3, and we'll create a def confuse student, spam, eggs, foo. Okay? And we'll do something like this. Okay? First off, I'll say spam plus equals 5. Increase spam by 5. Eggs plus, we'll multiply that by 2. So we'll double what eggs is. And foo we'll just set equal to 0. Why not? Okay? So we've got that. Okay? And now here's what I'll do. I will say, okay. I will call confuse student. It doesn't return anything, by the way. So I'm not adding them up into a new value. I'm not returning that new value because it's not the point of this one. Spam, eggs, and foo. Okay? Print spam, eggs, and foo. So my question is, what gets printed? Yes? Sorry? Uh-huh.
Wouldn't it cause an error because it's not within the function?
Which part?
Because spam equals 1 and equals 2 is not within the function.
These are in the function, and then I've just created these variables out here.
Okay.
So it's not going to cause an error because they're there, but it prints out 1, 2, 3. Why? Because this spam, eggs, and foos are just labels. They're name tags for whatever gets passed in. The way it works, okay, is that it's positional. Remember that when we have an error, let me try to give it a fourth one. When you give it too many arguments, it says it takes 3 positional arguments, but 4 were given. Positional is that key word. The way it figures out what goes to what variable is what came first. All right. So let's go ahead and do confuse student. And so these have no bearing about what's on the inside and what's on the outside, right? They're completely different variables. Yes.
If you put for print 0, 0, 0, would the answers be 5, 2, and 0? And then also would print 1, 2, and 3?
No. If they're all 0.
No, I mean.
Yeah. If I change this over to 0, 0, 0.
No, 3 lines all the way at the bottom. Or
Okay.
print that right there. If you put that, if you put numbers in there,
It would print the numbers. It would just print the numbers.
but it wouldn't add.
It wouldn't do. If I just print out the numbers, it would print out the numbers. Because you're telling it to print out the number 0, and whatever's in foo. Okay. These are complete. Yes.
Would it make any difference if you put spam equals 1, eggs equals 2, food equals 3 before the function?
Nope.
Okay.
No. Makes no difference. Excellent question there. Yes.
What if instead of like 1, 2, 3, you put like bracket 1 bracket? Like you basically had like 3 lists. Would it?
No. We're not going there yet.
Okay.
No list yet. Lists are right now everything we have to figure out that everything is positional first before we can start playing with lists. Okay? Yes.
Why isn't it incrementing by 5 and then multiplying by 2 and assigning foo as 0?
Excellent questions. So the reason is because is that these is what's going on under the hood, which is that we're copying stuff. That's why. Because the answer is that it is doing it to these. Spam, eggs, foo. It's not that it's not doing it. It is doing it. 640, 1, 2, 3. It is doing it. But here's what's going on. Okay?
You're updating the values and then you're printing it, right? Like you're
Right.
calling the function first and then you're printing it.
Yep. So here we've got spam. So here we're on the outside of the function, and here is our function, which is called confuse students, which is doing a great job of living up to its name. That's intentional, by the way. You're supposed to feel confused here because you're running on a few assumptions, and I'm trying to show you the way it actually works. Spam, eggs, And don't worry, it took me a bit to get this too. Spam, eggs, and foo. Okay? And now we have spam, eggs, and now we have foo. All right? So we said, now our line of code says that, one second. Our lines of code say that we do spam, is that we do this define function. This just simply registers it, okay? This says that confused student is a function with these arguments. Next thing we do is that we say spam, eggs, and foo are 1, 2, and 3 respectively, okay? And I'm really sorry about my handwriting. I know I should have gone into medicine as opposed to computer science with handwriting like this, but, you know, take what we can get. So now we call the function. The next line for this is that we call our confused students function, okay? That occurs over here. And we do spam, eggs, and foo, okay? And so we copy it over into, so this gets copied over into here, this gets copied over into here, and this gets copied over into here. It's a lot easier to see if I don't give them the same name, by the way. X, Y, and Z. Let's go ahead and just change this to X, Y, and Z. X, Y, and Z, right? It's a lot easier to see now if we don't give them the same names, right? I'll call them X, Y, and Z for a bit. So spam gets copied into X. This copies this into this, and foo and Z gets copied over here. They're copies, right? And so by changing this, making a change to X, Y, and Z, or as I've renamed them, is not going to affect the copy that's outside, right? And this is just the label we have for that copy. I labeled it X, Y, Z here, but I can label them whatever I want, including the name of stuff that is outside this function, right? So this gets copied into confused student spam. This gets copied into eggs, into confused students eggs. This gets copied into confused students foo. Make sense? So it's getting copied into those. Yes?
On iHope or Python?
I'm sorry?
Can you go back to the code?
Yes. Give me 1 second. For some reason, the whiteboard isn't playing well. Yes?
So if it's in the function spam plus equals 5.
Yep, this gets updated to 6. This gets updated. This gets multiplied by 2. This gets set to 0. And doesn't have any effect on the things that were outside the function.
And you said it's still happening using impress print or type print or return, right?
Right. Yeah, I'm just printing these values out to show you that that's on what's inside. I can even show you inside. Spam. There you go. Inside. 6 or 2 for 0. And I know you're looking over there, and I know your question about lists. And the reason you were asking about lists is that the way modern programming languages work is that they are passed by copy. Okay? So basically, whenever we pass anything into a function, we pass a copy of it. Okay? For basic information like numbers and booleans, okay? Those are copies of those values. For anything more complicated than basic numbers, which we won't have to worry about until we're done with exam 1, we're passing a memory location. So that's the answer to your question there. But for everybody else who's like memory location, don't worry about that until we're done with exam 1. Okay? So we have this. Now, okay. Now to be extra annoying, okay? Okay, so we've got 6, 4, and 0. 0 here. Now let's go ahead and switch this up. Still got 1, 2, 3 here, but now spam, foo, eggs, spam. Okay. So how does that work? Now, I was harping on earlier about how it's positional. Okay? How it's positional. Okay? So the call I just wrote down was, in case you missed it, was we are going to, I'm just going to call it CS for confused students. Haha. I said it's foo, eggs, and spam, right? That's the order. Everything is positional. So the first argument goes into the first argument over here. The second argument goes into the second. The third goes into the third. Foo would go over to here because it's first. Eggs would go same place because it's second. And spam would go over to here. So we would get 3. So according to the code, we would pass in 3 over here. See, it's 3. Foo is 3. So that's a 3. So we'd pass in a 3 over here. That's a 2. We'd pass in a 2 over here. And if we have a spam over a 1 over here, we'd have a 1 over here. My suggestion is, if you get into questions like these and these are starting to drive you mad, rename on your test, just like cross out the names, okay, and like just replace them with something easier to remember, like X, Y, and Z. So you're not having that namespace collision, as we call it, where you're not having multiple things named the same thing. Okay? So here we pass in 3. Spam would get 3 is spam. Spam would be incremented by 5, which gives us 8. 2 times 2 is still 4. And then foo, spam, 1 gets passed into foo. Foo gets set to 0. That's still 0. 8, 4, 0. And on the outside, it makes no difference, right? What we're doing here. So that's the two. So the 2 rules to understand when we're passing things in: it's positional, and the names on the inside are the names on the inside. They don't reflect what's on the outside. You can ignore the names on the outside of the program. If it is considered bad practice to try to if there's a variable on the outside of the function that you want to use, it's considered bad practice to try to call it. Instead, you want to pass it in as an argument. You want to add it to this list of things that you're passing in. It's possible to call it from the outside, but it's really bad practice to do that, in my opinion. Because, again, for the same reason, you don't want to get yourself confused as to what's inside and what's outside of a function. Okay, now the good news is that when you're programming, you're never going to really encounter this in the wild. Okay? Again, this really only exists on for exam purposes, where it's deliberately confusing like that. Okay. So now, with that said, let's go ahead and take a look at using a function together with some other, let's go over the other topic, if statements, and we'll use functions in conjunction with that. Okay? So let's go ahead and does student pass? Let's just go and call that does pass, which takes in a grade. So we're going to write a function here, which takes in a grade and says, does the student pass or not? Okay? And we'll say that what we'll say is that we want the student to pass if it's a 70 or above. Otherwise, they should, otherwise they don't fail. Otherwise they don't pass the class. So an if statement is fairly straightforward. An if statement is composed of 3 parts. It's got the if, you've got the statement that we're going to fill in, and then you've got a colon, which simply indicates there's going to be an indentation upcoming. So only one part really needs to be filled in, and it's one of those what we call Boolean statements, and they're the ones you've been dealing with when in math classes whenever there's been. They're very similar to what you've been doing with inequalities, right? Where you basically would have something like 3 plus x is greater than or equal to 5, something like that, right? Here, though, we're going to resolve that into a function. So in this case, how do we know if somebody's passed? If their grade is greater than or equal to a 70. Greater than or equal to, that's how we do greater than or equal to. It's not equal to or greater than. Okay? It's greater than or equal to the 70. And yes, it's totally valid if you want to flip it around and do the 70 first, but linguistically, this is what makes sense to me. So if this is true, we're going to do something. In this case, we are going to return true. Remember, returning is is just simply giving us information. It says we're passing information out of this. Else, return false. Now, two things here. We could greatly simplify this. We're not going to, but we can actually greatly simplify what I've just written here. But for although just because it's simpler and shorter doesn't mean it's easier to read. Okay? But here what we've got is if else. So if statements have an optional else. Okay? If this is true, do this. Otherwise, do that. Make sense? That's what the else statement does. Else's don't have any conditions because it's the default. It's basically, okay, if this didn't work, then do this. There's no in between. So if you aren't doing the first thing, you definitely have to do the second thing. You could also just, not run, you could also just optionally, for a lot of cases, you won't need a second if statement. So you're not going to need an else statement. The else statement is optional, but for a lot of things here, we're just going to be using, especially with a question that asks, is this true or not? You'll probably be using an else. So I'll register. So I'm going to run this. It registers that function. And what I'm going to do is I'm going to just simply type it in here. Does pass. And let's go ahead and say an 84. That is a passing grade. Does pass. A 62, false, right? So what it does is says grade. Is grade greater than or equal to 70? In this case, it was. Similarly, if does pass 70, right? The greater than or equal to means greater than or equal to, right? True. If instead we had grade is greater than the 70, that'd be rather unfortunate because then we'd have does pass false because that's not greater than. Yes?
Why doesn't true or false have to be in parentheses?
Doesn't have to be in parentheses. A return doesn't need to be in parentheses. Okay? A return basically is kind of special in that way. Okay? It's not a function call. It's that's actually the big reason why it's not. It's not a function call, it's a statement. It's saying, so there's some subtleties in return, like the fact that it stops a subroutine, it stops a function once we hit one, but we don't really need to go into that yet. Let's go ahead and write a more complex statement now. Def, what grade? What letter? Which we'll take in a grade, and what I'll do is I'll give you back the letter grade. Okay? And for right now, what we're going to do is rather than using a print statement, rather than using return, I'm going to use prints, and then I'll go to return. Okay? So what letter? So if grade is greater than or equal to, and I'll switch this back to an equal to, if grade is greater than or equal to a 90, print A. So let's go ahead and actually just go ahead and start with this because I want to demonstrate a few things. So if grade is greater than or equal to a 90, okay, so let's go ahead, then print A. So first off, if I do this and I type in what letter 90, it says it'll get an A. If I type in 7,240 and 40, that's a very good grade, and that student gets an A. And if I type in an 85, I get nothing because all I've written is if it's greater than 90, print out an A. Well, it's not, so we're done with the program. Great. No. The second is that order matters. Okay? Remember, it's going to go top down. So if I do if grade, so this is going to demonstrate two things. If grade is greater than or equal to, and again, spacing, always do what makes it most readable for you. Greater than or equal to 80, print B. Okay, what letter? 85. Okay, it's going to, if grade is greater than or equal to 80, 85 is greater than or equal to 80, print B. Great, we printed out a B. Is 85 greater than or equal to a 90? No, it is not, so we don't print out anything. Make sense? So now, of course, I'm going to do a 95 to demonstrate a point here. BA. Remember, computers is an evil genie. It's going to do exactly what you say, not what you mean. Okay? If the grade is greater than or equal to an 80, 95 is greater than or 95 is greater. If it's greater than or equal to a 90, that's greater as well. So it does the first and it does the second. Okay? So same thing if we, and it does the B first because we did B, because it checked the B first. If we instead put this, which is the way I want it to be, by the way, 90, then 80, it's going to do AB, right? Let's go ahead and just put this over here first. That way I don't have to keep calling it manually. So what letter 95 does AB? If grade is less than or equal to 70, okay, print C. All right, ABC. Not very, because we have three separate if statements. These are independent if statements, okay, meaning that they don't really care about each other and how each other work. If one works, great. If two work, great. They're both going to fire. What we want is like interdependent if statements. Statements where if one is true, where only one is going to be true because we only want to get one letter grade, right? Right? If I got an A, getting a B and a C as well in the same class is going to lower my GPA, right? So I don't think it's possible in that system, but hey, you get the idea. So what we can do here is that, remember we had an else. Now, this would be rather annoying to do. Else, if that was true. Else, if this was true, do that. Don't do what I'm doing, please, because it's evil and horrible and looks terrible, right? Right? See how it just kind of just curves in like that? That's kind of awful looking. It's terrible for readability. Else, so if this is true, do this. Otherwise, check if it's greater than 80. Otherwise, check if it's greater than 70. Instead of doing it like that, we have if, we have else, and then we have one more statement. In other programming languages, it's called else if. In here, it's just called elif together. And it's the way we kind of glue multiple if statements together. So let's just kind of show what happens as a result. If I throw 95 at it, it's going to print out A. If I throw 75 at it, it's going to print out C. Only one of the things is going to fire. So what it does, and it does it in the order you check them in. So first off, if 75 is greater than or equal to a 90, no, it is not. Okay, since it's not, I'm going to check else. I'm going to check the other one. Is it greater than an 80? No, it is not. I'm going to check this one. 75 greater than 70? Yes, that's true, so I'm going to print out that one. So let's go ahead and finish that off. Elif grade is greater than or equal to a 60. Okay. Print D. And else print F. And I've said this during the first lecture, but some of you weren't here or weren't listening. Basically the minimum grade you can get in this class if you actually try, and I don't mean that like, oh, if you submit things in theory, you should be able to get this grade. The minimum grade you can get if you're actually doing participation and actually like showing up and turning in assignments and like is a D. I don't give Fs. Fs are reserved for basically for people who don't turn in anything and or cheat. Make sense? So, like if you're missing your exams and like if you don't have exam grades in at the end, I'm like, well, that's an F because, because you didn't participate, you didn't try. But anyway, so now we've got this kind of tree here. If it's not, so 75 prints out that. If I do a 42, it's going to print out an F. Why? Well, it checks against 90, 80, 70, and 60, and it's none of those are true. So by default, it does the last one, which is F. F says all the other cases, right? So now, mind you, again, nonsensical stuff which you should test. 8,000, right? And then, of course, -1 is less than everything else. So that's going to be an F. Make sense to everybody here? Okay. So Boolean statements are fairly straightforward. And you can make them more complicated with and statements, as we'll see in a bit, or statements. So, for instance, over here, like, what do I mean like that? X, so let's just type it in over here on the side. X is equal to 5. X, so I'm going to write a Boolean statement. X is greater than 7. False. X is greater than 7, or X is greater than 3. So you'll want to watch the videos on and or statements, but those are basically the two kind of joining operations we have for joining multiple Boolean statements together. And join things that all have to be true together, and ors, if you've got an or statement, only one thing has to be true, right? And it's not the exclusive or, like it is like one, as long as at least one thing is true in an or statement, the entire statement is true. So with the last half an hour, let's take what we've learned and kind of take a look at the beginning of the blame Pope Gregory XIII. Okay? So, and we will continue, we will get this started and we will continue this on Tuesday. But we're going to get started because we have plenty of time. So this used to be another homework assignment I used to give. I liked it because it goes over if-else statements, switch statements, just ignore that. Modular arithmetic, string indices, converting into strings. It's again from Savage's book. So the program task is write a program that, given a string as an input, tests if a given string is a valid date in the Gregorian calendar. Named after Pope Gregory XIII, who was pope from 1572 to 1585. He commissioned and instituted that calendar, which calendars don't sound like a big deal, but let's just go ahead and take a look at George Washington for a second, okay? What does this have to do with anything, right? George Washington. Okay, George Washington, and then it used to have a footnote right here. February 1732 to 1799. So, born. Personal details, right? Says he was born February 22nd, 1732. And then if we look down over here on the personal details, it says he was born February 22nd, 1732. Old style, February 11th, 1731. This makes it kind of annoying when you're doing American history, which represent the change from the Julian calendar to the Gregorian calendar. So contemporary records at the time can be a bit confusing whether or not they were using the old Julian calendar or the newer Gregorian calendar. And the Gregorian calendar is, by the way, what we use today. That's just our standard 365-day calendar. In fact, Julian calendar works basically almost the same way as a Gregorian calendar. The reason that they exist, and these exist, is because we have leap years. This year's a leap year, right? How did you know? It's divisible by 4, right? Is the year was the year 2000 a leap year? Is the year 2100 a leap year? Yes, no? No. 2100 is not a leap year. Because that's the thing. You've always been taught the Julian rules for leap years. So here's the thing. It was a trick question, sorry. The astronomical year is our calendar is 365 days. Our calendar year is slightly less than 365 and a quarter, okay? Slightly less than 365 and a quarter. If it was exactly 365 and a quarter, then doing a leap year every 4 years would make sure that the seasons don't drift out of sync with the month, okay? However, slightly less. So as a result, we need a new day added in every so often to adjust for that, but not every 4 years. Okay? Because it's not like 3 1/4, it's like 365.24 something. Okay? So every so often we don't want to have a leap year. So here's the rules for what a leap year actually is. And again, you can blame Pope Gregory for this. That's why it's named this. Okay? So dates in the US, I'm going to be using US formatting. That's kind of necessary here because other countries actually use different formattings. So month, day, year. Okay? Here's all the valid dates are from 1 to 12. September, April, June, November, 30 days. All the others have 31 except February. February has 28 days except when it's a leap year, in which case it has 29. So the rules for a leap year are, according to the Gregorian calendar, as follows. A year not divisible by 4 is a normal year. So if it's not divisible by 4, no problem, not a leap year. If it's divisible by 4, it's a leap year except when it's divisible by 100, except if it's divisible by 400. Sorry, it's a horrible way to explain it. Let's go ahead and Gregorian calendar. Every year that is exactly divisible by 4 is a leap year, except for years that are exactly divisible by 100. But these centurial years are leap years if they are exactly divisible by 400. So 1700, 1800, 1900 are not leap years. If you are fortunate enough, and I hope you are, to live to 2100, then you'll be able to correct everybody who thinks it's a leap year when it's not. But 1600 and 2000 were leap years, and you can see that, why you were learning it in school, your teachers didn't have to worry about that rule. Every 4 years worked for them. Yeah, the Gregorian calendar makes this exceptions to follow the calendar year. It makes the average calendar year 365.2425 days, which is closer to the real 365.24.22 days that it actually takes the Earth to go around the sun. Okay, so example, 1644 is a leap year, 1645 is not, 1600 is a leap year, 1700 is not. So the nice thing about the leap year, and just as an aside here, by the way, this is for the Gregorian calendar. A lot of religions still use their own calendars based on their religion. For instance, I can personally speak for Judaism that you've got 12 months. It's a lunisolar calendar, and every so often you get a leap month added in for the exact same purpose. It's not this is just what happens with different calendar systems. So it's worth doing a 10-minute dive on Wikipedia to see, there's actually different kind of calendar systems and they all do different things. It's very fascinating. Okay. So we will not have to worry about the leap year nonsense today because that's only going to be one day out of a bunch. What we're going to try to do is we're just saying, given a date, is it a valid date? Right? Is this day a valid date? And we only have to worry about a leap year if it's February 29th. Okay. So let's go ahead and get started. First thing we want to do is that we should ask the user for an input, test if the string is a valid date. So first thing we're going to do is ask them to enter a date in this format, and then we have to extract the month, the day, and the year. I know we can at least do that during the time. So let's start a new program. Let's just call it blame. Or you can call it leap year. Doesn't really matter what you call it. Okay? I'm going to call it blame. Okay, the first thing we're going to want to do is basically we've got we can split it up into two parts. That's all. When you've got a big program, you always want to split it up into discrete parts. So the first kind of natural split we can make is get the date, and then the next part we can do with that, the next natural part is test the date, right, to see if it's valid. Now, the test the date, that it's its own way to split it up, but let's not worry about that right now. Let's just focus on getting the date. Okay, how do we get the date from the user? We use the input statement for that. So let's write an input statement and say, input, please enter month / dd / year, right? That way they know the format and it reminds you what the format is, okay? And that will give us, and we'll just call that the date, okay? The next part, what we'll want to do is that we will want to use an operation that you should have already read about called slicing. Okay, you should have already had exposure to that. You should watch the videos on that. But if you haven't, I'll put the instructions up on the screen in just a second. But the point being is that we want to extract the month, the day, and the year from this. Okay, so and preferably as numbers, but that's easy enough to fix if you don't do that. So let's go ahead and write down month is equal to day is equal to, obviously you don't want to put the question marks in your code. That's what you want to fit, those are the blanks for you to fill in. And then year is equal to, so how do I get those things? Because let's assume that the user enters in the data and they do it correctly. We're going to always assume they enter it in correctly. So what we're going to get is, okay, we're going to get some number we get a number here, a number here. Let's go ahead and call it XX/XX/XXXX, right? Where X is some digit, right? So they're going to enter in this string. And each string, right, and hopefully you've been watching your videos, each one has a character. So each one is a specific character at a specific index. So how do we get those specific characters? And the answer in Python is that we use slicing, which is in this PDF if you want to download it, but right over here is the instructions on how to slice. So first, to get a small portion of the string, we can use the slice notation, which allows us to save a small part of the string. The format is string name, open bracket, index to the end index. It goes, and just like range, it goes up to but does not include. Okay, so here's an example. String is equal to my name. So S2, so I've got string 2, string 3, string 4, string 5. This would hold my, well, would hold capital M my. 3 to 6 would hold nam. 3 to 6. It's because this is character 0, 1, 2. Index 3 up to but not including 6. So 3, 4, 5, 6. It holds nam because it's up to but not including 6. This is a pretty cool thing you can do. If you leave off the ending, it just simply goes up to the end. So starting from 3 going all the way through the end if you leave it off. Make sense? It's a pretty nifty trick there. And then if you just get S3, it's not a slice, you're just getting a single character, right? So the slice notation is always beginning, colon, end. Okay? So what we want to do here is, let me just pull up nothing to do with if statements or anything like that now. We're just looking at the slice. So go ahead and use this over here to try to write slice notation for the month, the day, and the year, right? So basically you're just saying, okay, here's an example. Let's apply it to this. Make sense? Okay, so go and have at that.
So you're slicing this, the one I have up there, that I have it labeled here. Yeah, let me just make that announcement, because that seems like an easy misconception to make.
Right. So the string you're slicing on is not this string over here, but you're slicing on this string, what the user gives as the date. Okay? So you're slicing on the date, and that's why I have this listed here, because those are the indexes that, okay, these would be the indexes that you need to use, and here's the string itself. So I saw a lot of people get there. Okay? And if you haven't, as long as you're thinking correctly that, or you're learning about the slices, you're doing good. So for the month is this value over here. So, right, the month is going to be the first two characters, right? So we want to start at, so these all concern going over the date, right, that we're given. Okay, so next what we want to do is that we need, that each of these are going to be a slice. Okay. And so now we want the first two characters. So obviously, so in that case, because we want to start with the first character, we want to put 0 there, right? This is index 0. And we want to go up to, but not include this slash. What is this slash at? It's at index 2. So 0 up to, but not including 2. Next, for the day, that's this, and that's why I wrote this in over here in monospaced font, right? Why I have this, because, you know, it's very useful to kind of write it down, especially when you're starting, oh, this is index 3. So I want to go start at index 3, go up to, but don't include index 5, right? It's up to, but doesn't include index 5. Remember, the reason we do this is so that we can figure out how big things are very quickly by saying 5 minus 3, oh, it's 2 characters long. 0 minus 2, that's 2 characters long. Okay? 6. Year starts at 6, and it goes up to, well, that's a very interesting question, isn't that? So there's 2 ways to do this. You could go, well, 6 goes up to, but doesn't include 10, right? There's no index 10, so it doesn't include it. And another way to do that is 6 up to the end, right? Just leave it blank. Similarly, actually, if you leave off the beginning and just do it like this, it says from the beginning up to including 2. But again, there's nothing wrong with being explicit like I am. So let's go ahead and print that out. Print month, day, and then year. Okay. I'm going to enter in 1999. And it gives me 1999. We can convert them into integers because that will be easier for later, right? Int. Okay. Don't have too much more time. Today's Thursday, so we'll definitely pick up back with this. But I'm going to show you one very nice thing that I didn't really get taught about Python. I just kind of stumbled into accidentally. You'd think that this would crash it, but apparently there's no out of bounds exception when you're doing slices, which is really, 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 really helpful. So you can basically, so if you go on beyond the end, it will just simply go to the end with slices. It's pretty nice. Yes? You have a problem? What's up?
Basically, it isn't showing me the year.
Is it, did you try to print it out?
Yeah, like not showing, yeah.
See, and did you input the year?
Yeah.
Just take a quick look.
So it's like 0, 0.
Oh, you didn't, you need to run it. You need to run it, right? And then you gotta enter it here. So, 01 / it's not gonna look, unfortunately it doesn't look like nice right now. So let's go ahead and clean it up a bit.
Isn't show the year.
Like this. So I had a /n so that we got a new line to put it on.
But like it's not printing the year for some reason.
And then that should look better.
Like date 0, 1, 5, it's just showing 0.
0101. 1, 2, year. So we enter month. Date is equal to. Oh, because you did date rather than day is there. So you replaced. So you made it. Yeah. There you go. Okay. So let's see. So yeah, slices are an extremely useful tool there. So the next part is, so I'm going to write the outline for the next part, and we'll come back to that on Tuesday. So here's the outline for the next part, which is we need to test the date. In order to test the date, we need to split it. We want to basically figure out if it's a valid date. First off, there's nothing going to be disqualifying about the year, right? Now, how many days are in a month depends on what month it is. Okay? And then finally, and so basically if we enter in a negative day, it's going to be a bad day. And if we enter in like something like the 32nd day of April, that's going to be an invalid day, right? So, but also like the 30th of February will always be an invalid day. So what's invalid depends on what month it is. So we don't need to really check what year it is because any year is basically a valid year. Even a year far in the future would be a valid year. And so we only have to check against the month and the day. And we'll check month first because once we figure out what month it is, that's how we can know how many days we need to check for. So figure out if month is 30 days, 31 days. February, it's going to be its own category, right? Because it's unique. Because it's got 28 or 29 days. Or invalid. What would be an invalid month? A zeroth month or a negative month or like maybe a 13th month, like, or 20th month, right? If somebody wrote 20/20/2020, that would be an invalid date because there is no 20th month. Okay. Maybe in some weird calendar that you're writing for your fantasy world, but not in the Gregorian calendar, which is what we're checking here. Okay. So that will be our first task. Once we figure that out, we will then check, okay, is the day valid? We only really care about the year if it's a leap year. And we only care about a leap year if it's February and if it's the 29th of February. Make sense? So that's where I'll leave us, and we'll come back to this on Tuesday.